So let's move on towards lecture number 12 of Clayden book. Okay. So unit 1 is going on from Clayden book and we are at lecture number 12. So we will understand the meaning of this particular paragraph in this class. But before that, have a look at these two structures. Okay. This particular structure and this particular structure. Have a look at these two structures. The thing is that this is the structure of sucrose. This is the structure of sucrose, which is table sugar. What is sugar? Sucrose. Sucrose means table sugar. Okay, the sugar which you use at home. Table sugar, that is sucrose. Okay, that is sucrose. It is isolated from sugarcane or sugar beet. It is either isolated from sugarcane or sugar beet, and it is a white crystalline solid. It is a white crystalline solid, and its structure is like this. It is a crystalline solid because it forms a specific arrangement of atoms. Okay, crystalline solid is a solid which has a fixed arrangement of atom. Crystalline solid is a solid which has a fixed arrangement of atom. So sucrose, which is isolated from sugarcane or sugar beet, it is a white crystalline solid. Its structure has been shown here. It is table sugar, common table sugar which you eat at home. Now over here have a look at the structure of iso-octane. I have already talked regarding iso-octane in the what is octane rating lecture, which was prior to this, just before this, immediately before this in the playlist there is a lecture called as octane rating. Okay, so in that octane rating I had discussed the compound iso-octane. So what is the structure of iso-octane? This is the structure of iso-octane, or this is the structure which is drawn by advanced aspirants, and this is the preliminary structure. Okay, so this is drawn by students at lower classes and this is drawn by students at higher classes. Okay, so this is the difference. Now I want to tell you that there is a mistake in Clayden's second edition. I am making this video from Clayden's second edition, and there is a mistake in this book. The mistake is that the IUPAC name of iso-octane, has been written as 2,2,5 trimethylpentane. It has been written as 2,2,5 trimethylpentane. Correct it. It is not 2,2,5. It is 2,2,4 trimethylpentane. It is not 2,2,5 trimethylpentane. It is 2,2,4 trimethylpentane. So how the IUPAC name has been derived? Let me tell you. The chain is like this: 1, 2, 3, 4, 5. Okay. So 5 carbon chain. It is visible to you. 5 carbon chain is there. 1, 2, 3, 4, 5 carbon chain. On second carbon 2 methyl groups are there. 1 and 2. 2 methyl groups are there at second carbon. So 2, 2, 2, 2 because of this, and 2 methyl groups because of that, double 2. And on the fourth carbon there is again a methyl group. So there are overall 3 methyl groups. 1 methyl group, 2 methyl group and 3 methyl group. 2 methyl groups are present at second carbon. 1 methyl group is present at fourth carbon. Okay, so 2, 2, 4 trimethyl, 2, 2, 4 trimethyl pentane. In the book it has been written 2, 2, 5. In the book it has been written as 2, 2, 5. It is wrong. It is not 5. 2, 2, 4. Okay, remember this thing. So iso-octane has a IUPAC name 2, 2, 4 trimethyl pentane. It is a major constituent of petrol, the petrol which we put in cars and automobiles, vehicles, moped and car. The major constituent of that petrol is iso-octane. Okay, it is a volatile means it converts to vapor easily. Okay, what does it mean by volatile substance? It converts to vapor easily. The substances which convert into vapor easily are called as volatile substances. Okay, inflammable liquid, what does it mean by inflammable? Inflammable means can catch fire easily. Okay, what does it mean by inflammable substance? Inflammable substance is a substance which can catch fire easily. So it is inflammable, that means it can catch fire easily. Okay, so this is the properties of iso-octane. This is the IUPAC name. It is major constituent of petrol. It is volatile, that is it readily converts into vapor, and it is inflammable liquid, that is it catches fire easily. Now let us move on towards our paragraph. Among the 16 million that have been made. Now if you don't know the previous paragraph, you will say what does it mean. So it is actually saying that 16 million is this figure. Okay, 6 zeros. 1 million has 6 zeros, so 16 million will also have 6 zeros. Okay, so among the 16 million compounds, organic compounds, non-organic compounds, okay, 16 million non-organic compounds, that is stable organic compounds. Okay, when the author was writing this book, at that time 16 million organic compounds were known. In the year 2013, when the author was writing this book, at that time 16 million organic compounds were known at that particular time. There are all kinds of molecules with amazingly varied properties. So among the 16 million molecules, stable organic molecules, there are all kind of molecules with amazingly varied properties. So obviously every molecule is not going to have the same property. Okay, the property will differ from molecule to molecule. Okay, what do they look like? Okay, so what do they look like means how are their structures and all those things, and how is their physical appearance and what is their structure. How is their physical appearance and what is their structure? They may be crystalline solids. Okay, so for example, this is a crystalline solid. Crystalline solid means a solid having a specific arrangement of atoms. Okay, a specific arrangement of atoms or molecules, fixed arrangement, that is called a crystalline solid. Oils means you must have seen the cooking oil at our home. Okay, the cooking oil at our home is an organic compound. The cooking oil which we use at our home, it is an organic compound. Okay, so oils might also be there in this 16 million molecules. Crystalline solids might be there. Okay, oils might be there, waxes might be there. What does it mean by wax? You must have seen candle wax. So waxy solids means similar to candle wax in appearance, similar to candle wax. Okay, so those are called waxes. Plastics, what does it mean by plastics? Plastics means high molecular weight polymers. Okay, high molecular weight organic compounds means compounds containing a long chain of carbon atoms. 1000 atoms or more. Okay, long chain of carbon atoms, those are called as plastics, and they are used to make ice cream containers, they are used to make switchboards. Okay, so multiple applications. So these plastics also come under the category of this 16 million stable organic compounds. Okay, plastics also come under that category. Okay, elastics like rubber. Okay, now rubber is not an organic compound, but I am telling you that some organic compounds might be there which are elastic like rubber. Some organic compounds might be there which are elastic like rubber. Okay, rubber is also an organic compound only. Rubber is also an organic compound. It is elastic organic compound. Okay, actually rubber comes under the category of plastics as well as elastics. Because in rubber also a large number of carbon atoms are joined in a chain. Okay, a large number of carbon atoms are joined in a chain in rubber also. Okay, so rubber is also elastic. It can be stretched and it will return back to its original shape. Okay, it can be stretched to a large extent. The rubber can be stretched to a long extent and it will come back to its original shape when the force is removed. Okay, so this is the thing. Now mobile liquids. Okay, what does it mean by mobile liquids? Mobile liquids are the liquids which can flow, which have the ability to flow. The liquids which have ability to flow from one place to another, they are called mobile liquids. For example, water is a mobile liquid. Mercury is a mobile liquid. Okay, mobile or volatile liquids. What does it mean by volatile liquid? I have already told you what is volatile liquid. Volatile liquid is a liquid which is readily converted to vapor. Volatile liquid is a liquid which is easily converted to vapor. So volatile liquids or gases. So in this 16 million organic compounds, stable organic compounds, there might be gases also. Okay, so the familiar the examples of molecules familiar to us include, familiar ones include sugar. This is the sugar structure. A cheap natural compound. It is a cheap natural compound. Sugar is a cheap natural compound isolated from plants. So it is isolated from sugarcane and sugar beet. Either sugarcane or sugar beet. It is isolated from that. Okay, as hard white crystals. So it has hard white colored crystals. Okay, when pure, it has hard white crystals. This sucrose or table sugar has hard white crystals when it is pure. Okay, and petrol. petrol a mixture of colorless. Now colorless means they do not have color. So petrol is a mixture of colorless. Volatile means they are easily converted to vapor. Flammable means they easily catch fire. Hydrocarbons. So mixture of colorless, volatile, flammable. Flammable means easily catching fire. Volatile means easily converted to vapor. Colorless means lacking color. Okay. So petrol is a mixture of colorless, volatile, flammable hydrocarbons. Okay. Iso-octane is a typical example. Iso-octane is a typical example among these 16 million stable organic compounds in the world. Okay. Iso-octane is also a typical example. Iso-octane is also a typical example. And because of this iso-octane, this is the structure of iso-octane. Okay. It is also a typical example of that. Molecule, organic molecule, and it gives its name to the octane rating of petrol. Because of this iso-octane, we give the name to the octane rating of petrol. Now what is octane rating of petrol? I have already told you in the previous lecture. Okay, so I am not telling that here. So iso-octane, it gives its name to the octane rating of petrol. Okay, so this was all about this particular paragraph. Hopefully you have understood the paragraph and hopefully you have enjoyed the lecture. Thank you very much.